CIT 1121, Module 13, ICMP, Internet Connection Management Protocol. This particular module has just two submodules, ICMP messages and ping and traceroute testing. I put these in the opposite order. I just think it's a little easier to go to ping and traceroute first, and then talk about the messaging styles second. So ping and traceroute tests. Let's take a look at the next slide. And this slide gets into just regular ping tests, and I think everyone's done some pinging already. We're into chapter 13, and one of the ways that we can check for connectivity is we're going to use a tool that's going to tell us if we have connectivity at layer 3 between devices. So if we just run a ping's going to run off of ICMP, and we're going to bounce a request off of another device. We're going to say, hey, if you're available, please respond back, and we'll get an idea of if we've got communication or not. There's a whole bunch of packet tracers that are based around this that you'll do. And a couple of things I wanted to point out, and they did a nice job here, is they identified that sometimes when you ping something for the very first time, the first ping request will fail. And that's usually just due to the fact that the first one maybe take a little bit more time than the other one. So for instance, if you go to ping an IP address, you may not have the corresponding MAC address for that particular IP address. In this case, it's pinging 192.168.20.2. If 20.2 is not in your ARP cache already, you start the ping and the timer starts for ICMP that says, hey, you know, this is an unreliable communication and we're going to start the clock. And if I don't get anything back in X period of time, I'm going to say that I didn't get a response for this particular packet that I sent out. So clock starts, but we still have to run an ARP request to get the MAC address. So there's a little bit of overhead time in that first connection. Sometimes it'll take 2. In packet tracer, sometimes it does take 1 or 2, sometimes even 3 before the ball really starts going. So keep that in mind. If you get a failure and then you get 4 successes and you're like, oh, should I be worried about this? You should not. You should not be worried about that. One failure, especially if it's the first one, and then 4 successes is very normal. If you just hit the up arrow and hit enter again and run it through, it'll ping through all 5 of them, no problem. And just for the basic nomenclature here, a dot is a failure and a exclamation point, we're going to call it a bang, is a success. So 1 failure and 4 bangs, so that's very good. There's nothing to worry about there. Another thing I wanted to point out here about pinging is a lot of times when we have IPv6 stuff, we have to type in something different in the command. Like when we put an IP address in on an interface, we do IP address for IPv4, and then we do IPv6 address for IPv6. As far as ping or traceroute is concerned, put in the IPv4 address or put in the IPv6 address. You just use the command ping, and it will work. Okay, so keep that in mind. Moving on to the next slide. Just talks about pinging a loopback. This is not a big deal anymore. We've talked about loopback addresses before. And the whole point of the loopback address is to ensure that the TCP/IP stack on your computer is functioning the way that it's supposed to, so that you know that there's no corruption in the TCP/IP instructions on your machine. So if you were to ping in IPv4 127.0.0.1 and IPv6 just ping ::1, those are both tests to check your TCP/IP stack. So if TCP/IP is functioning correctly on your machine, you'll get responses. If it's failing, then you won't get responses. The operating systems that we're normally working within, the Linux operating systems and the Windows operating systems that we're using now, very rarely are they getting a corruption with TCP/IP anymore. So most likely the TCP/IP stack is okay, but if you're running out of answers, you've got a question you can't answer and you're not sure, pinging your loopback will tell you if your computer is doing what it's supposed to do. If it's failing, it's easy to fix. And I'll be honest, I don't think I fixed a TCP/IP stack error based on a loopback coming back incorrectly since like Windows 95 or maybe Windows 98. But it's been a really, really long time. TCP/IP has been a part of the base part of the operating system for Windows and Linux for ages. It does not get corrupted very often. If it did, you would just select the checkbox next to TCP/IP, remove it, re-add it. You may even have to restart your computer, and then that would go ahead and fix that issue. Same idea with a Linux problem if you had a Linux problem on that. The next slide gets into the idea of pinging the default gateway, which is always a really good idea. So whenever you're looking to troubleshoot something, one of the things that you'll want to do is try and figure out where the problem's at. And there's some really great packet tracers in this chapter and the next couple of chapters where you're going to have to use ping and traceroute to figure out where a problem lies. So one of the things you can do is you can just start pinging different devices. So for instance, you could check your IP address with an IP config, and then you could see what your default gateway is, and you can try and ping your default gateway. If you can ping your default gateway, that means you can get to the edge of your network. You can get to your router. So the problem that you may be having is probably not between your device and your router. It's probably further up the line. A lot of times, this is a really, really important response, because if you're using a regular internet connection and you can't get out to the internet, but if you can ping from your PC to your local router, it means that the problem is most probably on your internet service provider's side. It is not within your network. So the response then would be call your service provider, right? So keep that in mind. Pinging a remote host, and this just says, if you can ping up to your router, then you can then try to ping all the way across to get to the device that you want to get to. This is a pretty cool slide, and it just shows the routing table of the router there. We see F0 and F1, and this particular side is one network, and this particular side is a different network. And we're going to cross this router right here. So just keep in mind that the MAC address that you're going to use to get from your device on this side is going to be the MAC address of that interface. And when it gets forwarded over to F0, it's going to do an ARP for the destination, and the destination device is going to respond back with its MAC address, and it's going to pass that address across there. So ARPing in IPv4 works the exact same way. There's no difference, and there's no insights into ARPing for that. Traceroute is just a utility that is a series of pings with different time to lives that are posted. So every time you cross a router, your first router, you'll get one back on your entry, and then you'll get another one on your exit, and then entry into every router after that. You'll get a response back from your device letting you know, hey, this is how far I got towards my destination. This is very, very helpful command if the problem that you've got is within the fabric of your intranetwork. Then traceroute is something that you're going to be able to use. A couple of things about traceroute. Traceroute, when you use it in a Windows environment, a Windows command line, or from PowerShell, it's traceroute. It's tracer T. If you're on a Cisco device, you're going to run traceroute from a switch or a router, then you'll type in the whole word traceroute. So tracer T doesn't work. You'll find that out really, really fast. Every once in a while, you'll get an asterisk that just said that it's lost, or you won't get a response back from a device. It is common for some administrators to turn off responses to ICMP packets as they pass across their device, just for security purposes. And that's all they're talking about here, is that you'll get a list. There are some, once again, really good packet tracers that you can do that will let you really expand and see exactly how traceroute works.